All right, so the title for these notes is Law of Signs. And this one is the ambiguous case. So the two scenarios that we like because they're straightforward and easy are the ones that we did on the front of that packet. And so angle, angle, side, and angle, side, angle, we like these. These are straightforward. So angle, angle, side means you have two angles and then the side that's not in between them. And then angle, side, angle means you have two angles and the side that is in between them. All right, so we like those. Those both tell us law of signs and they're both pretty straightforward. The ambiguous case is angle, side, side, or side, side, angle if you want to be more school appropriate about it. So this is saying that you have two sides and an angle that is not in between them. Okay, and I just remember it that the ambiguous case is a pain in the angle, side, side. Get it? Okay. Nobody laughed? That's fine. All right, so here is the example problem. Was that like a delayed reaction? I get it. A pain. She said a pain in the angle, side, side. All right, so we're going to deal with triangle ABC where we have side A is 5 centimeters, side C is 7 centimeters, and then angle A is 40 degrees. So we're not going to get rulers out because that would take too long, but we're going to draw this as accurately as we can. So I'm going to go ahead and draw. Does that seem like that could be 7 centimeters? But that would be dependent on how big you are as a person. That might be average, but not everybody would have the same. All right, so 40 degrees, 45 would be like right in the middle of that, so 40 degrees would be like a little bit less.
Is this one with the right angle?
Huh?
Is this one without the right angle?
This one doesn't have, when we do law of sines and cosines, they typically don't have a right angle. All right, so there's our 40-degree angle. So what I want to show you guys is that if we think about drawing the side that has 5 centimeters, it can go two different ways, and that's what makes this ambiguous. Anyone know what the word ambiguous means from like English class? It means vague. So this situation is vague, it's not straightforward. Okay, so this is vague. I don't know why they didn't just call it the vague case, but ambiguous means the same thing. So the reason that it's ambiguous is because the third side could go this way and be 5 centimeters, or it could swing in and go this way and be 5 centimeters. So see how, regardless of how I drew it, this side is still 7, and that angle is still 40, and that third side is still 5. So it's a vague situation because that given information doesn't just draw one triangle, it could have two different triangles. Okay, so that's what makes it vague. All right, so what we are going to do is, now that we know that this is an angle side side case, anytime you're looking at a problem and it's an angle side side case, you are always going to draw two triangles because it could be two. It's vague because it could also just be one triangle. And it's possible they gave you information that doesn't fit anything, and it could be 0 triangles if you get an error message. Okay? So anytime the information they gave you is angle side side, you have to check to see if it's 0 triangles, 1 triangle, or 2 triangles. Okay? So we're going to go ahead and draw 2 triangles, and I'm not going to draw them like perfectly to scale because that would take a lot more energy than I'm willing to put into this problem. So 40 degrees right here, 7 centimeters, 5 centimeters. And then I'm going to draw the same picture again. Yes.
Is one-sided sheet would be like this?
Should be, yeah. So what we do to start is we set up the law of sines just like we did on the worksheet and just like we did in the notes from last night. Okay, so I'm still starting off by looking at the angle and the side that correspond to each other. Okay, so that will still happen just like it did before. So here I'm going to say 5 divided by sine 40. And the part that's a little bit different about these problems is that when you do this next, there is one specific variable you have to solve for next, okay? And the reason is, if you look at this, we have side B that is labeled as 7. We have angle B that is not labeled. But if you look at side C and angle C, both of those are variables. You guys see that? So I cannot look for anything that has to do with C next because that's two variables, a variable for the side and a variable for the angle, and that's too many variables for me to solve for, okay? So my second step in this problem has to be to solve for angle B. I have no choice. That's what I have to do next, okay? So now I'm going to say that that equals 7 over sine B. Yeah, so we can't possibly do anything with side C or angle C because both of those are variables. Angle C is not there, side C is not there. But when I look at angle B and side B, I can see that only one of them is a variable because side B was given to us. Angle B was not. So I have to use this one next because it has one variable, but the other thing that's given is a number. Okay? So we don't want to start off by writing an equation with two variables because then we get stuck right away. We can't solve anything. Okay, so here we're going to do the same thing we did last time. We're going to cross multiply. So I'm going to get 7 times sine 40 equals 5 times sine B. And then what do I have to do to get sine B by itself? Divide by 5. So I have 7 sine 40 divided by 5 equals sine B. And how do I get the B alone? You can't divide by sine. What do you do to get rid of a sine? Sine inverse. Okay? So the way that we solve for B is we do sine inverse of this whole thing. Okay? So I'm going to show you guys how I usually type this in to make it not so hard on myself. So what I usually do is I start here and I say, all right, 7 sine 40 divided by 5, because that part of the problem at least seems similar to what you did on the front page. So what we did when we were doing the front page problems is we did one thing times another and we divided something over, right? Okay. Then I have to do sine inverse of whatever that decimal happened to be. Okay. So what I can do now is I can hit second sine. And then to pull that decimal down there, I can hit second, and then ANS means answer. So it will pull that decimal down perfectly, okay? So second sine, second answer. That's how I type it in quickly, okay? And then it will give it to me. Your other option is you could type it in all at once if you want. So you could do sine inverse, and then you could type in 7 sine 40 divided by 5. Both of those things will accomplish the same purpose. Okay. Say it again. So we just solved for angle B, so this is degrees. Okay. So we're going to say, as a result of this, we can say angle B is approximately 64.145 degrees. Okay. All right, now when we do these problems, we need to start storing some numbers because these are messy decimals, right? And all the other answers are going to start to depend on these messy decimals. So I'm going to go ahead and say that this I'm going to store as letter B. Are we okay with that? Okay, so I'm going to hit STO down here to tell my calculator to store it. And then I'm going to hit alpha B. So I'm telling my calculator store that decimal perfectly as B. And then on my paper, I'm going to put a B with a circle around it, just so that I know that that's how I stored it, so I don't get confused later. Okay? All right, so in my picture, I'm going to go up here and I'm going to label this one as 64.145 degrees. Okay, now this part is the weird part, so if you want to do this part in another color, you can. If you want to get a highlighter out, if you just something, this part is the weird part that everybody always forgets, okay? So you have found B in the first triangle. The way that you find B in the second triangle is you do 180 degrees minus angle B. And that goes back to what we learned when we were doing, did we learn this yet for you guys? We did not. We learned this next unit. Never mind. You just have to memorize this. I'm sorry. All right. So in your calculator, you're going to do 180 minus B. And that is angle B in the second triangle. Okay? So not hard to find. It just seems like a weird process. I will explain how we knew that we could do that next unit, because that's when we learn it. Okay? So 115.855 degrees. I'm going to go ahead and label that in my second triangle. All right, and then we need to store this as a letter, and it can't be B because we already used it. So what could I store this as? L. L for Laura / the second angle B. Okay, so we're going to hit store, and then we're going to store it as L. Okay. So now, if you think about these problems, it's just like we are doing two different problems at one time. You guys see that? It's kind of like we're doing two different problems at one time. So we have to think back to what we did before when we were doing the easy, straightforward problems. If we had those, then we would have been like, oh, I have two angles, I just need to find the third one, right? You guys agree with that? Okay, so what I'm going to do to find angle C is I'm going to do 180, I'm going to minus 40 degrees from it, and I'm going to minus 64.145 because that's going to give me my angle C. Does that make sense? Okay, so I'm going to do 180 minus 40 minus what I stored as B. Can you see that? So I have two angles of the triangle, I'm finding the third one. Okay. So 75.855. Okay. And you guessed it, we have to store it. I'm going to go ahead and store this as C. Is that okay? Okay, so I have angle A and side A, angle B and side B, angle C, and I need side C. Okay, so just like before, I'm going to start off with the given information that was easy to work with, right? Side is 5, the angle is 40. That's really nice to set up. Okay, so I'm going to go ahead and write 5 over sine 40 equals C over sine of 75.855. And I'm going to remind myself that's what I stored as angle C. All right. So how do I solve for side C? Cross multiply like normal, right? So I'm going to say 5 times sine 75.855 equals C times sine 40. And I'm going to go ahead and type that in my calculator. So I have 5 times sine, and instead of typing around a decimal, I'm going to use C, because this is angle C, so I'm going to do alpha C. And then I'm going to divide the sine 40 over to the other side. All right, so side C is 7.542. That was centimeters. All right, so the first triangle is solved. We have all 3 angles, all 3 sides of the first triangle were done. Okay? So now what do I need to do to solve the second triangle? I have to find angle C. So I'm going to do 180 minus 40 minus 115.855, and that's going to give me my angle C. Okay? Do you guys remember what we stored this one as? L for Laura. So 180 minus 40 minus L for Laura. Okay, so angle C in this triangle is 24.145. And if you look at it, we're getting stuck in the same spot we got stuck before, because we have angle A inside A, angle B inside B, angle C, but we need side C. Okay, so just like before, we're going to store this. What letter do you guys want to store it as? Store it as O. So we could store it as M. Let's store it as M instead. I don't like using the variable O. Anyone know why? Because it looks like a 0. Okay, so we can store this as M. Okay, so now what should I do? We have side C that we're trying to solve for. What do we cross multiply? We have to set up the problem, right? Because I don't have any of that written down anymore. So now I'm going to say 5 over sine 40 equals C over sine, and this time angle C is 24.145, which is what we stored as M. And now I can say we should cross multiply. So I'm going to say 5 sine 24.145 equals C sine 40. Divide by sine 40. Okay, so I'm going to type in 5 sine of 24.145, which is what I stored as M, divide by sine 40. Okay, so side C on this second triangle is 3.182. Alright. Okay, so what that means, if you look at the picture that we drew, is that this is the second triangle right here. So you can see that this would be the angle B of 115 degrees, this would be angle C of 24, this would be that little side of 3.182. Can you guys see that, how that fits the little triangle? And that means that triangle 1 fits the bigger triangle. It has a smaller angle here, right, 64.145. This angle C would be bigger, 75.855, and then this side is definitely longer, 7.542. So it fits, our information fits our drawing. It's just little triangle is the second triangle, big triangle is the first triangle, okay? All right, so go ahead and grab your worksheets again. The next page on here is not asking you to solve the triangles. It's asking you to determine how many there are, okay? So the work that we have to do to determine how many triangles there are is just up to this point. So what we're going to do is we're going to draw the information. We're going to draw two sets of triangles. And we're going to do the first step where we solve for angle B. And we write angle B for the first triangle and angle B for the second triangle. Okay? And then we stop. Then we look at what we've drawn and we see if it makes sense. Okay? If it does make sense, you have two triangles. If it seems weird, it means you have one triangle. Okay? If in the process of doing this you get an error message on your calculator and you know you typed it incorrectly, then it means there is no triangle. Okay? It could be no triangle. All right, so let's go ahead and look at number 7. Again, just like I said before, I'm always going to go alphabetical on these. So even though it says YZX, I'm going to go ahead and do XYZ. And so my X is 45 degrees. My side X is 13. My side Z is 10. And when I'm looking at a problem like this, as soon as I can see that the given information is angle side side, as soon as I can see that, that's when I draw my second triangle. Kind of focus. If the information they give you is angle side or angle side angle, you don't have to test anything. You just say, oh, one triangle, we're good. Okay? So remember, the other cases were straightforward. This one is the ambiguous one. This is the one where it could be 2, but it could be 1. Or it could be 0. All right, so if we look at this, we're going to pick out the information they gave us to start with, where we have one side and one angle that are across from each other, right? What do you guys see? Yeah, the 13 and the 45, right? So we're going to say 13 over sine 45 equals, and then what other information should we use? We only have one option. We're going to use Z and we're going to use 10, okay? So 10 over sine Z, okay? So I'm going to be cross multiplying. I'm going to do 10 times sine 45 equals 13 times sine Z. So 10 times sine 45 equals 13 times sine Z. So 10 sine 45, right? And after I type this in my calculator, what am I going to do? Divide by 13. Divide by 13. So I have this decimal equals sine Z. This decimal equals sine Z. So how do I undo sine? Sine inverse. So I'm going to hit second sine, second answer, and remember that pulls that decimal down. Okay, so second sine, second answer. All right, so that tells me that angle Z in the first triangle is 32.951. So if the first triangle is 32.951, how do I find angle Z in the second triangle? We do 180 minus that. Okay, so the second angle, we do 180 minus the one we just found. Okay, so I'm going to do 180 minus angle Z, and I don't have to store the numbers this time because I'm stopping the problem after I do this. Okay, I only have to store all the numbers if I was going to keep it going. So I'm going to do 180 minus second answer again, just 180 minus that. I get 147.049. Okay, so if I label these I've got 32.951. Does this make sense? 45 and 32 when we got space for another angle? That one's reasonable, right? Nothing funky happened. The angle's not negative. It seems like it could work. Over here we have 147.049. Ooh, that doesn't work. Why doesn't that work? It's more than 180 already, and we haven't even found the third side yet. So when we do these problems, our first triangle should always make sense. There's no reason the first triangle wouldn't work. But the second triangle, when you look at that, you're like, ooh, that does not make sense. This only gives us one triangle. You did all that to say one. Yeah. All right, shall we try another one? Yes, okay. So H, then K, then P if we go alphabetical. K is 95. Side K is 34. P is 21. So I could see that the information they gave us is two sides and the angle that is not in between them, which means that what they gave us was angle side side. So two sides and an angle that was not in between them. That means I was looking at the ambiguous case. That's why I drew two triangles. Okay? So how do I start it? Okay, so 34 over sine of 95. I already started writing it wrong. Equals 21 over sine P. Oop, that's a B, not a P. Sine P. Okay. And then what do? I cross multiply, right? So I'm going to have 21 times sine 95 equals 34 times sine P all right, and then what do I do next after I've multiplied the left side out? Divide by 34. So I got rid of the 34. Sine P equals this decimal. So I do sine inverse, second answer. Okay. So angle P is 37.973. And then how do I find angle P in the second triangle? Subtract that from 180, so I do 180 minus second answer. And I get angle P is 142.027. That definitely doesn't work. That's way too big, right? 95 plus 142 is definitely over 180. All right, so how many triangles does this one have? Just one. All right, do you want to do another one or do you want to work on your own? Yeah.
You said that the first triangle would always win.
So
what would the answer be?
if you are trying to do the first triangle and you get an error message. So like if you end up, you know how we get the decimal and we do the sine inverse of the decimal? Right here you would get an error message, it wouldn't work. There's, of these problems 7 through 14, there's one problem that has 0. So you will get the error message one time. Just one. Okay?